These are a couple of excerpts from one of the Building Component Seismic Safety Institute recorded online, on-demand webinars on seismic sway bracing of suspended mechanical, electrical, and plumbing components. In general, specific references to building code paragraph or section numbers are based on the 2009 International Building Code, its referenced ASCE 7 standard, or the 2010 edition of NFPA 13. These seminars offer between 1.5 and 2.0 professional development hours, and the Certificate of Achievement for course completion will be emailed to you and available for immediate viewing and printing in your BCSSI account upon completion of course attendance and successfully passing the exam, which consists of between 15 and 20 multiple choice questions. The whole process only takes about 2 hours. These excerpts are intended to give a sense of the thoroughness of these webinars, so please visit www.bcssi.org for details on the available courses and get your certificate today for the professional development hours that you can earn. Some components are exempted simply on the basis of seismic design category. Seismic design categories are given a letter code from A to F, which is a calculated value. There are 2 calculations required. One uses the short period seismic map value, and the other uses the long period seismic map value. The higher letter value of these 2 calculations is the applicable seismic design category, which makes these calculations very important. Some computer programs, such as the SCOPE Seismic Calculation Program, calculate the applicable seismic design category according to the IBC formulas. The components that are exempted from the seismic sway bracing requirements based on the seismic design category are all MEP components in seismic design categories A and B, regardless of importance factor, all MEP components with a component importance factor of 1.0 in seismic design category C, MEP components in seismic design categories D, E, and F when the importance factor equals 1.0 and either flexible connections are provided between components and associated duct, pipe, or conduit, or the component weighs less than 400 pounds, and all MEP components in seismic design categories D, E, and F when the importance factor equals 1.0 and flexible connections are provided between components and associated duct, pipe, or conduit, and the component weighs 20 pounds or less, or a distribution system weighs 5 pounds or less per foot. The applicable seismic design category will be the higher letter code of the first and second seismic design category calculations. As mentioned previously, the letter code for the seismic design category will be used to determine whether or not seismic sway bracing is required, and also to determine the seismic sway bracing exemptions that are based on seismic design category. Since the calculation of the seismic design category requires 2 calculations, and the similarity between the 2 of them can be confusing, the 2 calculations will be dealt with separately. The variables required for the first seismic design category calculations have just been discussed. Those variables are S sub S and the site class. Now the procedure for the first seismic design category calculation can be described. First, the S sub S %G value is selected from the 0.2 second spectral response acceleration map or from the previously mentioned USGS online calculator based on the proximity of the building to the mapped contour lines. Remember to use the S sub S %G value in its decimal form. Second, determine the site class letter designation based on the available soils analysis or using the default site class D as described previously. The site-specific site class for the building may be available from the contract documents, the authority having jurisdiction, or the design professional responsible for preparing the soils investigation report. Third, select the site coefficient F sub A from the site coefficient table as shown below for the applicable S sub S and site class values. Fourth, calculate the value of S sub MS based on the formula S sub MS equals F sub A times S sub S. Note that the variable S sub ms, which is required to determine the value of S sub ds, has not been previously discussed. Continuing with the first seismic design category calculation procedure. In the fifth step, calculate the value of S sub ds based on the formula S sub ds equals 2/3 of S sub ms. And sixth, determine the seismic design category letter code, which can be A, B, C, D, E, or F, and are based on short period response accelerations, by selecting the seismic design category letter code from the short period response accelerations table, as shown below, according to the occupancy category described earlier, and the value of S sub ds calculated in step 5. Note that the value of S sub ds calculated in step 5 is used here and in the F sub p formulas that are used to calculate the horizontal and vertical earthquake loading. The second seismic design category calculation is required in order to determine which calculation has the higher seismic design category letter code. The higher letter code resulting from the two calculations will be the applicable seismic design category. Thank you for watching these excerpts from one of the Building Component Seismic Safety Institute courses on seismic sway bracing of suspended mechanical, electrical, and plumbing components. And please go to www.bcssi.org for more information and immediate access to these courses.